Hello everyone, I'm Javier Cifuentes-Faura from the University of Murcia in Spain. It is an honor to participate in this conference as a keynote speaker. Thank you very much to all the members of the organization for inviting me. We will talk about sustainability and mathematics with the lecture entitled Big Data, Sustainable Development Goals and Mathematical Techniques. This work has been co-authored with the professors of the University of Murcia, Ursula Faura and Matilde La Fuente. Big data is a fundamental tool in many areas. The collection, storage, and meaning of large datasets for information can create significant value for the global economy, as well as to improve the productivity and competitiveness on both businesses and the public sector. The use of big data makes it possible to collect, store, and analyze a large amount of data in order to establish patterns and obtain estimators that can make real-time decisions about a given target, improving its performance and obtaining benefits. The use of big data is on the rise as more and more organizations have to handle large databases and because of the availability and access to data due to globalization. Big data enables many companies to gain a greater competitive advantage over their competitors. Big data is not only used in companies and organizations, but increasingly also in the public sector, as it makes it possible to address many issues such as efficiency or productivity. In recent years, climate change, environmental degradation, or resource depletion have become growing problems in society. Therefore, governmental institutions and many collectives have mobilized to protect the environment and create a more sustainable world. In 2015, the United Nations adopted the 2030 Agenda, which enacted the 17 Sustainable Development Goals, aiming to achieve a cleaner and more sustainable world by 2030. With the emergence of big data, the aim is through data analysis to anticipate events and prevent environmental catastrophes or reduce environmental degradation, while at the same time achieving sustainable development. To measure sustainable development, it is necessary to quantify the phenomena that represent such progress through the indicators. The first set of indicators was published in 1996 in the form of a Driving Force State Response framework by the United Nations to assess economic, social, and environmental indicators which contribute to the achievement of the Sustainable Development Goals can show the current state and evolution of the environment, as well as major concerns, which can help policymakers to make important decisions based on the information provided. A growing body of work using big data and different mathematical models aims to establish ways to achieve sustainability. The aim of this research is to carry out a review of the scientific production on the use of big data in sustainability using some kind of indicator to measure in order to show and analyze the intellectual, conceptual, and social structures of the research, as well as its evolution and dynamic aspects. Systematic literature reviews are very useful for researchers because they help them to get deeper into the field of study, to learn about trends, networks, works, authors with the most citation, and to ask questions for future research. By means of bibliometric analysis, using the WOS Web of Science database, scientific production was quantified and its impact was measured, describing how certain fields of research are related and how they evolve over time. In addition, the works were classified according to their empirical or conceptual approach. In the case of an empirical paper, the country where the practical application of the work took place was obtained and grouped into three different levels: micro, meso, and macro, depending on the spatial scope of the document, the mathematical technique used, and the SDG work on were analyzed, as well as the type of sustainability indicator used. Specifically, the research questions were posed in the following terms: What are the main trends in scientific production on sustainability based on big data? Which SDGs do the papers relate to? At what spatial level were the empirical papers conducted? And what kind of mathematical techniques are applied? The type of research carried out in this work is exploratory, descriptive, and quantitative based on the techniques and tools of bibliometric analysis of the documents stored in the Web of Science database. This is one of the world's most important databases of bibliographic reference and citations. One of the metrics it offers is journal citation reports, the best known quality indicator and one that is also evaluated by organizations that assess research activity. The review process follows several distinct stages. First, time scale, as the importance given to sustainability has mainly occurred in the last decades, it was decided not to include time restriction, obtaining all the documents up to 30 June 2021. In the search of the existing literature in the Web of Science database, three words were always used, taking as a basis sustainable and big data, to which were added indicator, index, assessment, evaluation, measurement. Finally, the results found in each of them were joined according to the following sentence: sustainable and big data and indicator, or sustainable and big data and index, or sustainable and big data and assessment, or finally sustainable big data evaluation, or sustainable big data and measuring. The required document type was article, including also review article. A preliminary reading of the abstract was initially carried out, followed by a more exhaustive reading of each article to verify that it met the established inclusion criteria. From the search carried out, we have eliminated those works that use some combination of the keywords in a tangential way, without giving them the strict sense that our research pursues. After this filtering, 325 documents were obtained, of which 34 are bibliometric studies. The distribution of the keywords in the papers analyzed is shown in the figure. The most prominent keywords is big data, followed by sustainability, which is compatible with the search query. A new register was created to integrate the spatial dimension, micro, meso, and macro in the empirical documents. The denomination micro-level refers to the fact that the analyzed document performs its empirical application in companies or places located in a small territory. The term meso-level has been used when the work has been carried out in several places at the same time or in industrial parks. The term macro refers to the fact that the document has a global or country-wide application. It is also recorded which SDGs are being addressed, the type of indicator used, environmental, economic, or social, and the mathematical techniques used. The review presents a combined perspective of a bibliometric analysis together with the spatial level analysis, meso, micro, and macro, and the SDG considered. The number of publications per year is shown in the table. The first work using big data with sustainability indicators dates from 2015. The numbers of papers has been growing from 7 in 2015 to 101 in 2020, which fits an exponential function. In the first half of 2021, 61 documents with the above requirements have been found, and it is expected to continue at this rate, also following the exponential growth. The evolution of the average number of citations per year per publication does show a trend as regular as that of the number of articles. Over the study period, two distinct periods can be observed in the average number of citations per year. The first until 2019 with exponential growth, and then a significant decrease until the middle of 2021. The latest information collected is in June 2021. The distribution by areas of knowledge shows concentration topics related to environmental sciences, technology, engineering, computer science, and economics. The table lists the top 10 most represented areas. Environmental science ecology stands out with 142 papers and science technology and other topics with 121. It is evident that an article may be associated with more than one area of knowledge, so that there are overlaps between these areas. A measure of the overlap between each pair of knowledge areas has been calculated from the top 10 most used. This index is defined as the quotient between the publications included simultaneously in both areas divided by the publication belonging to at least one of them. The higher the value of the indicator, the more publications in common between the two areas of knowledge. The figure shows the value of the overlap measure for those areas that have some publication in common. Among the 10 included in the previous table, the areas of remote sensing and construction building technology share 12 papers, with 15 and 12 publications, so the overlap is high. Energy fuels with 21 publications and construction building technology with 12, as well as environmental science and ecology with 142 publications and science technology other topics with 121, also have many publications in common with the indicator greater than 0.5 in both cases. The figure shows in different shades of blue the countries in which there are different researches on this topic. People's China stands out with 466 authors, followed by the United States with 144, the UK with 88 and India with 86. Of the 325 manuscripts analyzed, observing the author of correspondence of each one of them, 30.5% are researchers from China, 8.9% from USA, 6.1% from India, and 5.2% from Spain. The rest belong to 45 different countries. This figure shows the top 10 countries of authors with the highest number of citations and those with the highest average number of citations per year. As expected from the previous results, authors from Chinese institutions had the highest number of citations of their papers, although if the average number of citations per year is taken into account, the United Arab Emirates University stands out. To study the behavior of author productivity, we use Lotka's law of bibliometric quantification, which determines the productivity of authors based on a discrete probability distribution. This law states that the number of authors publishing n papers is inversely proportional to the numbers of papers squared. The figure shows the frequency distribution of scientific productivity, showing that the level of productivity of the authors in this subject is small. As the simple count of publications of each researcher is an unreliable measure to assess their contribution to the scientific world, other indicators such as the fractional index, Fi, the total number of citations received by papers, the citation per article, and the average number of citations per year are considered. The fractional index takes into account the number of co-authors of each paper. The total Fi per paper is 1, which is shared among all authors under the assumption that each contribute equally. Of the authors with the most papers, it is Min Lang Seng, who has the highest fractional index, 1.4. The number of citations received by authors is an indicator of the impact of their work in the scientific community, although this not only depends on its quality, but also on other factors such as the prestige of the author, the topicality of the subject, or the journal of the publication, which will condition the dissemination of the word. Donald Huizing, with 3 articles, is the author with the most citations per article and per year. Min Lang Seng occupies the second position in the total number of citations with 7 documents and is in lower position citation per article and per year. In order to simultaneously take into account the number of papers, total citation and citation per paper, the H index has been calculated, which is not affected by having an excess of uncited papers or papers with many citations. Mainland stand out with an index equal to 6, and almost all the other authors in the top 10 have an index of 3 or 4. To distinguish between authors with similar H-index, the G-index has been calculated, which is the ordered number of the position in which the number of accumulated citations is equal to or greater than the square position number. In the study of direct correlation between the authors listed in this database, a group of 7 authors stand out, who assess the sustainability of various business activities, focusing on efficiency. The group listed in green studies the sustainability of 4.0 companies and the blue group sustainable agriculture supply chain performance. This table shows the ranking of the journals with at least 3 articles indexed in the Web of Science database, the area in which each of them works, the impact factor, and the quartile in which they are included. Most of these journals belong to the publishers Elsevier and MDPI. The distribution by journal shows that sustainability has the greater number of articles published, grouping its paper in the areas of environmental studies, green and sustainable science and technology, and environmental sciences. It is followed by Journal of Cleaner Production and Sustainable Cities and Society from Elsevier. If, in addition to the number of publications, the total number of citations and the H-index, G-index, and N-index are taken into account, the journal with the greatest relevance in the subject analysis is the Journal of Cleaner Production. This coincides with the thematic distribution presented above, in which the areas of environmental science are the most relevant in this file. Without taking into account bibliometric works, environmental sustainability is mainly studied, either exclusively, jointly with economic sustainability, with social sustainability, or with all 3 areas. The less analyzed type of sustainability is social sustainability. The SDG that has received the most attention is SDG 9, Build Resilient Infrastructure, Promote inclusive and sustainable industrialization, and foster innovation, followed by SDG 11, Make cities inclusive and sustainable, and further behind SDG 13, Take urgent action to combat climate change. SDG 6, Ensure access to water and sanitation, and SDG 7, Ensure access to affordable. The result of the was search in empirical works relating the spatial component to the type of sustainability studied in each paper. At the macro level, there is a predominance of papers that analyze the 3 types of sustainability together, and those that work only on environmental sustainability. Social sustainability is only analyzed at this spatial level. At the meso level, most of the papers consider only the environmental part, although there is also a high percentage of articles that analyze all 3 types of sustainability. At the micro level, the papers are more evenly distributed according to the type of sustainability addressed, with those analyzing the environmental component once again standing out. Most of the SDGs have been studied at all spatial levels. At the macro level, SDG 9 and 11 had the same weight. However, at the rest of the level, SDG 11 stands out from SDG 9. At the meso level, 21.3% of the works apply to SDG 9 and 32.4% to SDG 11. At the micro level, 24% are dedicated to SDG 9 and 26% to the 11. There are SDGs that are only analyzed at the macro level, as SDG 16 and 17. And now we go with the main conclusion of this study. Achieving sustainability is the most complicated situation facing our planet. With the emergence of big data, which makes it possible to manipulate and obtain information from a large amount of data, and the development of mathematical tools, ways are being sought to achieve the desired sustainability as soon as possible. In this context, it is very useful to know the existing scientific production and the use of big data to solve problems. All these through indicator and mathematical techniques. At the same time, it is important to see the relationship between the documents found and the Sustainable Development Goals in order to find out which SDGs are more attractive for researchers. The bibliographic database chosen to locate the scientific production on this topic was Web of Science. The number of publications has grown exponentially, which shows the enormous importance of these lines of work among researchers. The areas of knowledge that deal with this subject are related to environmental science, technology, engineering, computer science, and economics. The most productive research institutions are located in China, with the Dalian University of Technology standing out with publications that focus mainly on studies in the field of environmental science. China is also home to the largest number of scientific researchers, followed by the United States. Sustainability, Journal of Cleaner Production, and Sustainable Cities and Society are, in that order, the journals with the highest number of published papers, and together with International Journal of the Information and IEEE Access, cover 33% of the publication. Of this journal, the Journal of Cleaner Production is the most relevant in the subject study, taking into account not only the number of publications, but also the number of citations and the H, G, and M indexes. The environmental part of sustainability has received the most attention from researchers, followed by the economic and, to a lesser extent, the social. The greatest concern is with promoting innovation and entrepreneurship, Sustainable Development Goal number 9, and making cities more sustainable, SDG 11. In the empirical papers, the mathematical techniques used to analyze sustainability based on big data include multidimensional regression, neural networks, and the analysis of different indicators depending on the sector in which the research is applied. Methodologies based on fuzzy analysis, fuzzy analysis, multi-criteria decision-making, factor analysis, efficiency analysis, geographic information system, and optimization techniques are also used together with qualitative analysis, such as sentiment analysis. When taking into account the spatial level at which empirical studies are carried out, meso-level studies predominate, followed by macro and micro-level studies. At the macro level, the focus is more on analyzing the three spheres of sustainability together, with the works that only take into account the environmental dimension also being important. At the meso level, there are more publications on the environmental part. At the micro level, the papers are more evenly distributed according to the type of sustainability dealt with those that analyze the environmental component once again standing out. Most of the SDGs have been studied for all spatial levels. At the micro and meso levels, SDG 11 stands out against SDG 9. At the macro level, neural networks, qualitative techniques, regression, and geographic information systems are more commonly used. At the meso level, the most commonly used techniques are multi-criteria decision-making methods, and at the micro level, different indicators are analyzed, mainly environmental indicators. The results show that big data applied to supply chains, Industry 4.0, and the achievement of sustainable cities are the most important topics of current trends. One of the most interesting topics is the study of innovative solutions for supply chains within production with the aim of achieving environmentally, economically, and socially viable production. Among the main contributions of this research is that different branches of research in the field of sustainability analysis with big data have been identifying, and that, according to the analysis of the results, the growing role of environmental issues and Sustainable Development Goals 9 and 11 stands out. This is the end of the presentation. Thank you so much for your attention. You can see my email address on the screen, so if you have any question, please don't hesitate to contact me. Thank you.